Hello everybody, and welcome to my assignment for MS579, assignment number 2. For this assignment I had to use Try Hack Me. So let's begin. Okay, the assignment was to complete 4 rooms in Try Hack Me. These are the 4 rooms I chose. Introduction to Pen Testing, Vulnerabilities 101, OWASP, which stands for, I believe it's Online Web Application Service Penetration, maybe, and then DVWA, which I have no idea what it means, but it was fun. All right, let's start. So room number 1, what is pen testing? Well, a penetration test, or pen test as we call it, is an ethnically driven attempt to test and analyze the security defenses of an application to protect these assets and pieces of information. A penetration test involves using the same tools, techniques, and methodologies that someone with malicious intent would use, and it's kind of like an audit. So we kind of like simulate a hacker, a bad guy, and trying to get into the system, and we do this to try to prevent them from getting in, and or trying to find other ways to bolster the defenses, basically. But knowing that, we have to talk about hackers. So basically, hackers are the people trying to break into computers, right? Now, not all hackers are bad. So actually, hackers are sorted into 3 different hats, where their ethics and motivations behind their actions determine what hack category they're placed into. So let's get into this. The first one I'm going to talk about is the white hat. These are the good guys. These hackers are considered to be the good people. They remain within the law and use their skills to benefit others. For example, a penetration tester performing an authorized engagement on a company. So, somebody with a cybersecurity degree that gets hired as a penetration tester would be a white hat hacker. And these are the guys that, work for companies to try to stop the bad guys from doing what they do. Then we have the gray hat. And yeah, these guys are a little sketchy. These are the people that use their skills to benefit others, usually. However, they don't always respect or follow the law, I guess you want to say, or ethical standards, to be to be honest with you. An example of this is like somebody trying to take down a scamming site. So these are the vigilante guys, These guys are the guys that go in and mess with the guys that are trying to steal your credit card information by, sending you a bunch of emails and stuff like that. Technically, I guess they're not bad guys, but they're definitely not within the law. So, is it really ethical? You have to ask yourself that, I'll leave that up to you, but moving on, we have the black hat guys, and yeah, these guys are the criminals. These guys are like the Black Bart of hackers here. They're criminals, and they often seek to damage organizations or gain some form of financial benefit at the cost of others. For example, ransomware. They'll infect devices with malicious code and hold the data for ransom. Look, we see this all the time. And to be honest with you, it's out of hand. Banks, doctors' offices, government places, these are the guys that hack your stuff and get your information, and the next thing you know, you're getting a letter in the mail saying that you were involved in a data breach. These are the guys responsible for it. Not cool, But, when you leave tools in front of stupid people, they'll do stupid things. So in my opinion, black hat people are stupid people. Basically, they just do this stuff because, well, in my opinion, they just want to get caught. They want to make a name for themselves. So, yeah. But moving on. Now, we're going to get into the different modes of testing. Now, there are 3, black, gray, and white. But don't confuse this with the different hats, the black hat, the gray hat, and the white hat, okay? Those are for hackers. This is for testing. Black box testing is the first one we're going to talk about. And in a nutshell, black box testing, when you get into it, you basically have no knowledge of the system that you're trying to break into. So, knowing that, I'll explain a little bit more. This testing process is a high-level process where the tester is not giving any information about the inner workings of the application or service. The tester acts as a regular user, testing the functionality and interaction of the application or piece of software. This test can involve interacting with the interface. Some examples would be buttons. And then testing it to see whether the intended result is returned. No knowledge of programming or understanding of this programming is necessary for this type of testing. Black box testing significantly increases the amount of time spent during the information gathered and enumeration phase to understand the attack surface of the target. So think of this as, your average guy, trying to break into something. He's got no knowledge of anything. He's just trying to go for a joyride, That's the way I think of it. Gray box testing. Gray box is in the middle. Gray box people have partial knowledge when you're doing this type of testing, and we'll get into it. This testing process is the most popular for things such as penetration testing. It's a combination of both black box and white box testing processes. The tester will have some limited knowledge of the internal components of the application or a piece of software. Still will be interacting with the application as if it were a black box scenario, and then using their knowledge of the application to try to resolve issues as they find them. With gray box testing, the limited knowledge given saves time and is often chosen for extremely well hardened attack surfaces. So I'm going to try to give you an example of this. So let's say you're trying to break into a website that has a bunch of music on it, and you want to download the music for free. And you might have a username and a password, right? So you're going to try to use that. That's kind of like gray box. You have some knowledge, or you might have a password, or you might have a username. So you have some knowledge, but not all the knowledge you need to get into the system, right? That's the way I'm looking at it. And then white box testing, well, you got all the knowledge in the world about it. So this testing process is a low-level process, usually done by a software developer who knows programming and application logic. The tester will be testing the internal components of the application or piece of software, for example, ensuring that specific functions work correctly and within a reasonable amount of time. The tester will have full knowledge of the application and its expected behavior, and is much more time-consuming than black box testing. The full knowledge in a white box testing scenario provides a testing approach that guarantees the entire attack surface can be validated. I've actually had to do this at my old job. So we had a warehouse application, and I had to test it for vulnerabilities, making sure that everything worked right. Not only, maybe not so much about breaking into the system, but making sure that the system functioned as it should. Were there any vulnerabilities inside the system itself, like bugs that could happen? That's part of it too. Yeah, it can be tedious. Let's just put it to you that way. But anyway, moving on. So my test for this, I had some information. I was trying to break into an email service, and I had to get an IP address basically from a person, and then use that, and then try to change the IP address. It was weird, but anyway, I passed. So there you go. Look at that. I won. All right, next room. Vulnerabilities. Well, what are vulnerabilities? Oh boy, what are vulnerabilities? Well, a vulnerability in cybersecurity is defined as a weakness or a flaw in the design, or implementation or behavior of a system or application. An attacker can exploit these weaknesses to gain access to unauthorized information or perform unauthorized actions. The term vulnerability has many definitions by cybersecurity folks. However, there is a minimal variation between them all. For example, NIST defines vulnerability as, quote, weakness in an information system, system security procedures, internet control or internal controls, or implementation that could be exploited or triggered by that threat source, end quote. Vulnerabilities can originate from many factors, including a poor design of an application or an oversight of the intended actions from a user. There are a lot of different vulnerability types. I listed some of the more common ones. We have the operating system. There are vulnerabilities in those. These types of vulnerabilities can be found within the operating system and often result in privilege escalation. We have configuration misconfiguration based. These types of vulnerabilities stem from an incorrectly configured application or service. For example, a website exposing customer details. Yeah, like I said, I'm not sure if I said this or not, but I have a website with all of my music for the record label on it, and our whole catalog was exposed at one time. So yeah, that was not cool. Next one is weak or default credentials. Applications and services that have an element of authentication will come with default credentials when installed. For example, an administrator dashboard might have the username and password of admin. These are easy to guess by an attacker. Yeah, so you install a program, say like MySQL or something like that, and your server password is default by by default. You need to change that. If you don't change that, yeah, these are very common words that a hacker can use to get in. Okay, so next one is application logic. These vulnerabilities are a result of poorly designed applications. For example, poorly implemented authentication mechanisms that may result in an attacker being able to impersonate a user. Usernames, passwords, stuff like that. Human factor. Human factor vulnerabilities are vulnerabilities that leverage human behavior. For example, phishing emails are designed to trick humans into believing that they are legitimate. I'm not sure if I said this already, but I just had this happen to me. I had someone sent me an email and a text saying that one of my credit cards, and it had the last 4 digits of my credit card number on there, saying that I made a purchase on that day, and for a certain amount, and it caused my credit card to go overdrawn. But luckily for me, I have an app on my phone that I use to monitor my credit card. And when I checked it, sure enough, nothing. There was no overdrawn, there was no nothing. So somebody was trying to get me to click on a link in order to get the information to be able to use that credit card. I reported them. Yeah, fun stuff. Common vulnerability scoring system. So there are a couple of vulnerability scoring systems out there, and I'll go through a couple of them. This one is the Common Vulnerability Scoring System. It was first introduced in 2005. Or it's also called CVSS, and it is a very, very popular framework for vulnerability scoring and has 3 major iterations. As it stands, the current version is CVSS version 3.1, with 4.0 currently in draft at the time that I took these tests. A score is essentially determined by some of the following factors, but there are many more. Number 1, how easy it is to exploit the vulnerability. Number 2, do exploits exist for this? And number 3, how does the vulnerability interfere with the CIA triad? In fact, there are so many vulnerabilities that you've got to use a calculator in order to figure out the score of this framework. A vulnerability is given a classification out of 5, depending on the score that it has been assigned. Now, the next one is Vulnerability Priority Rating, or VPR. The VPR framework is much more modern framework than the vulnerability management developed by Tenable. Oh, I'm sorry. Let me reiterate that. The VPR framework is a much more modern framework in vulnerability management developed by Tenable. Sorry about that. An industry solution provider for vulnerability management. That's who Tenable is. This framework is risk-driven, meaning that vulnerabilities are given a score with a heavy focus on the risk of vulnerability poses to the organization itself, rather than factors such as impact, like with CVSS. Now, unlike CVSS, VPR scoring considers the relevancy of a vulnerability. For example, no risk is considered regarding a vulnerability if that vulnerability does not apply to the organization. For example, they don't use the software that is vulnerable. VPR is also considerably dynamic in its scoring, where the risks that a vulnerability may pose can change almost daily as it ages. VPR uses a similar scoring range as CVSS. Now, I said I put a table here, but I forgot it. I have it, but I didn't put it in. But however, there are two notable differences that VPR does not have: a non-informal category, and because VPR uses a different scoring method, the same vulnerabilities will have a different score using VPR than when using CVSS, obviously. Okay, there's also another thing that we have at our fingertips. That's the National Vulnerability Database. Now, the National Vulnerability Database is a website that lists all publicly categorized vulnerabilities. In cybersecurity, vulnerabilities are classified under common vulnerabilities and exposures, or CVE for short. The CVEs have the formatting of this: CVE -year -ID number. For example, the vulnerability that the famous malware WannaCry used was CVE -2017-0144. So that's how it works. NVD allows you to see all the CVEs that have been confirmed using filters by category and month of submission. And there are a lot of them, let me tell you. So for my test, well, this one was easy. I was able to walk through it with no problems. Unfortunately, there were no notes to take with this one, but I passed it. And basically, all you had to do was just complete this room. Just go through what I just went through, and that was it. So, room 3, online web application service pen testing. Yeah, this one was fun. So, first thing I have to point out is what a web application is. A web application is like a program that we can use without installation, I should say. So it doesn't have to be on your computer, right? If we have a modern standard web browser such as Firefox, Safari, or Chrome, we can use it. Consequently, instead of installing every program you need, you only need to browse the related page. So think of it as a web version of a program. Your online banking web application, if you go online, you can use online banking, app, or go to the website. That's a good example of it. So web applications and databases. Now, the idea of a web application is that there's a program running on a remote server, okay? A server refers to a computer system running continuously to serve the clients. So think of the internet, okay? So we're a client. We're tapping into the internet, which is a bunch of servers. In this case, the server will run a specific type of program that can access web browsers. By web browser. Now, with databases, there are several of them. I listed 3, okay? And these databases are usually hosted on the back end, which means they're hosted on the server. And then we as clients can connect to them and get information from them, or we can send information to them to store. So one of them is called a product database. This database contains detail about the products, such as your name. Could have some images, maybe some specifications, and a price. There's a customer database, and it contains details related to customers, such as your name, your address, your email, your phone number. Then there's a sales database. This is what we expect to see. Each customer has purchased. Now they pay for this. So it's basically a bunch of receipts, stuff like that. And then you have an employee database and all these other ones. So, attacks. Well, when you attack something like this, you can do a bunch of stuff with it. And I kind of listed one here. So, let's say, suppose an attacker manages to exploit or hack the web application that we're looking at and steals a customer's database. In that case, this will lead to a significant loss for the company and its customers. So, let's say somebody breaks into the web app, and they get a list of people's names, addresses, phone numbers, credit card information, right? So then the user enters an item name or related keywords into the search field, and this is how they get this stuff. The web browser sends the search keywords to an online shopping web application, for example. So let's say we're hacking a shopping web application. and we used a program in there, and it gave us all of these keywords to get into the system. We have different products. We have a products page. We have an ordering page. We have, customers that bought stuff. Examples of all that. So the web application queries and searches the product database for the submitted keywords. The product database returns the search results matching provided keywords in the web application, and then the web application formats the results on a friendly web page and returns them to the user. Thus, we get all the information we want, can use it, and boom, we can hack into it. So, for my test, I was told to access a website with a database that contained information on employees and a database of items. I had to use different user ID to access the system and then modify the list of items that were sent out, causing a delay and confusion. So basically what I had to do is I had to find a way into the system and sabotage their planned shipments so I can delay them. So what I did is I had access to a user, and I found a user ID. So I figured there's got to be more user IDs. So the specific user ID was the user ID 11. So I started going up 12, 13, 14, see if there were any other users, right? Nothing. So I went down 10, 9, 8, 7, and I found some. So one of them I found had some information on it that I could type in, and it gave me a password to get into the planned shipments, and I was able to hack that and then sabotage it. And because of that, looks like I win. And there's your proof right there. So the last room, DVWA. Yeah, this was pretty challenging. So DVWA is an awesome virtual machine commonly utilized in training and testing of new tools. This room is unguided and acts purely as a testing environment. So basically, it gave me a scenario and I had to try to hack into the system without any help whatsoever. But it did give me some tools. So the credentials to log in can easily be found online, but they're also included in the hints below, should you prefer to take the easy route. Well, I didn't list the hints, but there were some tools here. Remember, we're using a what we call a command prompt, basically a command box that we type stuff in instead of using like Windows where we click on the icons. We do it old school and actually type it in. And right here are some different things that we can use to do that. Oops. Well, anyway, I won, but I will tell you this. It was difficult. I had a heck of a time. I had to look up stuff. I even had to go to a YouTube video. And just when I thought I was going to have to give up, just when the timer was about to run out, I got it. And I beat it, and I won. And believe me, it was hard. I am by no means a hacker. So that was it. Alright, so yeah, so okay, I'm sorry, I don't know why I jumped like that, but anyway, so I had to use all the skills I learned for the room, and it was time. I was making no progress, but I kept at it. I had to search the internet for answers and even watch a YouTube video, and this is what it looked like right here. I had to get an IP address, and then I had to use some login information and try to get all of that stuff. I learned a lot, and it took time to solve it takes time to solve puzzles. You can't just do this stuff. You have to do research, and it takes time. Sometimes your head you will be banging against the wall, and you feel like you can't get it. You just got to keep at it and keep at it and keep at it, and eventually you will. And just when I thought I was going to fail in timeout, I won. I kept at it, and I got it. That's the end of my presentation. Again, my name is Jeffrey Koss. I am a student at the University of Advancing Technology. This class is MS579, Ethics and Security Software. And I am a Master of Science student for Software Engineering. Thank you guys and have a wonderful day. And if you think I did a good job, give me a good grade because I love good grades. Thank you guys and have a wonderful day.